All right, problem 2-50. For each quadratic function below, use the method of completing the square or averaging the intercepts to rewrite it in graphing form. Remember, that's also called vertex form. Then state the axis of symmetry and give the vertex of each parabola. Try to use each method at least once. Well, the first one, letter A, I have f of x equals x squared plus 6x plus 15. Now, if you go and try to factor this, you'll realize that it does not factor. So what I'm going to use on this problem is the method of completing the square. So we're going to look at that here. So there are several methods that are taught for doing this. The way I prefer to do it is to go ahead and get rid of my c term here. So I'm going to subtract 15 from each side. I like to keep it consistent and do the same thing every time rather than adding in and doing different values in order to create my perfect square trinomial. So I'm going to keep my f of x in here. So I have f of x minus 15, and that should equal x squared plus 6x right now. Now we want this side to become a perfect square trinomial. So we're going to have to figure out what value is missing. So what I'm going to do here is I'm going to treat this as x squared plus 6x plus blank. So I need to come up with the value there. But if I add something to this side, I need to make sure that I add something to the other side. So I'm going to do f of x minus 15 plus blank. This is the biggest mistake I see when students complete the square is they'll add something to this side to complete the square, but they'll completely forget to add it to the other side. Your equation is like, it's got to stay balanced. You have to do to each side to keep it equal to each other. So what I'm going to do here is I'm going to look at what number do I need to add here. Well, remember, this is your b term, and you need to always take half of b and then square it to get this value right here. This is the same thing as taking it in your generic rectangle and putting the values that you need to put in. Okay, I think in Algebra 1 you were taught to put your x squared here and then to split your 6x. When you split your 6x, that's the same thing as dividing b by 2. So when you do that, there's your 6x's, but you've divided it by 2. Now with the generic rectangle, you end up with x plus 3 and x plus 3. And then when you do 3 times 3, you get 9. That's where the squaring comes in. So this is kind of like a little shortcut instead of having to draw out your generic rectangle. So I take 6, I divide it by 2, and then I square it, and I get 9 up here. But if I add 9 to this side, I need to add 9 to this side over here. So the next step here, we're going to simplify the left side. Negative 15 plus 9 is going to give us negative 6. So we have the function f of x minus 6 is going to equal. And the whole reason we did this is so that we can factor this into a binomial that is squared. So, and as you see from the generic rectangle here, we're going to end up with the quantity of x plus 3 squared. Now remember, this number inside of here is either half of the middle number or the square root of this one. Think about it. That's where that 3 comes from, because 3 times 3 gives you 9, or you had your total 6x's and half of those were 3. Last step, we just need to get it into that graphing or vertex form, so we're going to add 6 to each side. So now we have f of x equals the quantity of x plus 3 squared plus 6. Now they want us to state the axis of symmetry and give the vertex of each parabola. Well, we know our vertex right now is the point -3, 6. Remember, that comes directly from this formula. Y is equal to a times the quantity of x minus h squared plus k, in which case your vertex is the point hk. So you're always taking away h, so it means you kind of have to look at the opposite value here to get your x coordinate of your vertex. Then our axis of symmetry, so our AOS, is going to be x equals -3, because it has to be a vertical line through this x coordinate. So there is your answer for letter A. You've got your function, your vertex, and your axis of symmetry. Let's look at B now. Letter B. We have x squared minus 4x plus 9. With this one, if we look at it here, our factors of 9 are 9 and 1 and 3 and 3. Neither of those add to 4, so let's look to complete the square again. So we're going to take it, let's recopy it. Y equals x squared minus 4x plus 9. Let's go ahead and subtract the 9 from each side. So we now have y minus 9 is going to equal x squared minus 4x, in which case I want to complete the square, so I'm going to go ahead and just recopy here with my blank so I can add in whatever value I use to complete the square. So remember, again, we're going to take half of our middle term and square it. This time I'll just do the shorter method there. B is -4, so we're going to take -4 divided by 2. Remember, that came from this number right here. And then we're going to square it. So -4 divided by 2 is -2. And -2 squared is going to give us +4. So I'm adding 4 to the right side. I'm adding 4 to the left side. Y minus 9 plus 4 is going to give us y minus 5. This side should factor into x minus 2 squared. And then we're just going to add 5 back to each side here to get y equals the quantity of x minus 2 squared plus 5. Our vertex is going to be the point hk again. So remember, we're going to take the opposite of what it looks like. It looks like it's x minus 2. But since it's x minus whatever h is, our h is 2. Our k value is this constant that's being added out here. So we have the 0.25. And that would mean that our axis of symmetry, or our AOS, is going to be x equals 2. There's letter B. Let's move on. Let's look at letter C. Now for letter C, we're going to have f of x equals x squared minus 8x. Now rather than doing all of them as completing the square, I'm going to go ahead and do one of them here as averaging the intercepts. That's the X-intercepts. So let's take it now, and if we're going to be looking for the X-intercepts, we're going to need to substitute an output value in at 0 here, because all the points on the x-axis have a y-coordinate of 0. So we're going to say 0 equals x squared minus 8x. So we need to find, our number one goal here is to find the x-intercepts. That's going to allow us to get our axis of symmetry. which gives us the value of h, which is our x-coordinate of the vertex. And that will allow us to do the last step there, and that would be to find the k value, which is the y-coordinate of the vertex. So let's do it here. We're finding the x-intercept, so we've set it equal to 0. This should factor, so we're going to have x times the quantity of x minus 8 equals 0. Now we can use our zero product property, so we know that x equals 0, or x minus 8 is going to equal 0, in which case we get x equals 8, or x equals 0. That is our two x-intercepts, or those are our two x-intercepts, which means then if we want to figure out what h is, if you just envision now what we've done is we know that we have a parabola and it's got an x-intercept here at 0, 0, and it's got one over here at 8, 0. So we know that that axis of symmetry is going to run directly down the middle here. It's going to be straighter than what I drew, but that means that we know already halfway between 0 and 8 is 4, but if you think about averaging the intercepts, that's what you should get. 0 plus 8 divided by 2 equals 4. So that is the x-coordinate of the vertex. Okay, now our vertex is the point 4 comma something. To get the k value here, we're going to take this 4 and plug it into the function. So we're going to say f of 4 equals 4 squared minus 8 times 4. 4 squared 16, 8 times 4, negative 32, and we get f of 4 equals negative 16. So our vertex is the point 4, negative 16. What does that do for us? Well, we know we're at 4. We're down here like negative 16. You'll see our parabola would just go up like this. So the last step is we still need to figure out, our equation, and then have our vertex and our equation for the axis of symmetry. So now that we know that the vertex is 4, negative 16, we can write our equation. The a value here is 1, so we know that a is 1, h is equal to 4, and k is equal to negative 16. So y equals a, which is 1, so that we don't have to write it in there, times x minus 4 squared, and then we have minus our 16. There is our equation for this parabola here. The last part of it there is the axis of symmetry. Well, if we're looking at all the points here where x is equal to 4, that is the axis of symmetry. The AOS, or axis of symmetry, is x equals positive 4. Let's go ahead here and let's just get into the last one. D, x squared plus 7x minus 2. And one last time. Sorry, I forgot it there. All right. Y equals x squared plus 7x minus 2. Now this one we have an odd number in the middle here, but I'm going to go ahead and look to complete the square here still, even though it looks odd. I think we probably need some practice with that. So let's go ahead here. Let's add 2 to each side to get rid of the c term. So we have y plus 2 equals x squared plus 7 halves. I'm sorry, not 7 halves. I'm jumping the gun. It's just 7x. We want to complete that square, so y plus 2 plus blank equals x squared plus 7x plus blank. So to get our value that's missing here, we're going to take our middle term. We're going to take 7. We're going to divide it by 2. And then we're going to square it. So 7 squared is 49. And 2 squared is 4. So we have 49 over 4 that needs to be added to each side. Well, that was easy enough there. The next step, so we need to take it and we need to combine our like terms here. So we have 2 and 49 fourths, which is the same thing as 8 fourths plus 49 fourths. And that's going to give us 57 fourths. And that equals, on the other side, we can factor this now. It should end up being x plus either half of this or the square root of this. So x plus 7 halves squared. Last step, go ahead and subtract the 57 fourths from each side. And we will end up with y equals the quantity of x plus 7 halves squared minus 57 fourths. And remember, our directions up here state that we need to also get our vertex and our axis of symmetry equation. So our axis of symmetry would come from the x-coordinate of the vertex. The x-coordinate of the vertex is going to be the opposite of this number. So negative 7 halves. And the y-coordinate is negative 57 fourths. And our axis of symmetry comes from that. X equals negative 7 halves, or negative 3.5. All right, that's it. That's problems A, B, C, and D from 2-50. I tried to take a little extra time to explain it there, so I know this video is a little longer. Hopefully you got out of it what you needed. Thanks for watching.